For today's video, we'll be talking about the formation of an acetal in ketal. We start with the structure here. We have an aldehyde, right? If this process goes with reactants of H plus hydrogen ion with any carbon chain, R stands for any carbon chain with an alcohol, right? We would get a structure that will look like this. OR, oxygen with the carbon chain, and an alcohol. This is called a hemiacetal, right? Hemi means half of an acetal. Two R groups so far, where they were going to half. Now this is in a reversible reaction. If we keep going, we would get another structure just like that, but this time we will have two carbons, two carbon chains, right? OR and OR, right? And this is called a acetal. As you can see, we went from OH to OR, full conformation. Now let's see another example here that we have. I'm going to draw another structure. And this structure is ketone. If ketone goes in the same process, we would get the same structure, except without the hydrogen, right? But we get OR and OH. And this is called a hemiketal, half of a ketal. If we keep going forward, we get the same structure, but with OR and OR. So we went from an OH to an OR, and this is called a ketal. So you can see the difference here. We have aldehyde, hemiacetal, acetal, ketone, hemiketal, and ketal. Let's do an example to see how this works. Let's start with an aldehyde, and this is reacting with 2-methanol, let's say 2-methanol, and also H plus hydrogen ion. Now, how we do this is where that carbon is where that double bond of the oxygen's at, right? We remove it, and all we do is just add 2 methanols, right? So we have OCH3 and OCH3. And this is called an acetal, right? It went full all the way through. Let's do another example here. This time we have a ketone plus 2 methanols. So same thing as the aldehyde, right? And H plus hydrogen ion. We get the same thing, right? OCH3 and OCH3, but this is called a ketal. So they both work the same way. Let's do another example here. We have this ring. So this is a ketone, right? This reacts with, let's say, hydrogen ion, right? H plus, with also, let's say, there's isopropyl, an alcohol on it. So we have that carbon. We remove that double bond oxygen and add 2 oxygens, right? Now we add the isopropyl part. So if we don't write the hydrogen, we'll write that isopropyl part, and we draw it like that. And with the other side as well. So basically, we went from a ketone, reacted with the alcohol, and we got a ketal. Let's do the mechanism for this. We have a ketone here. Now, this mechanism for a ketone is the same thing as an aldehyde, right? The mechanisms are the same for both. So we have this ketone that's reacted with any carbon chain with OH, an alcohol, right? So first things first, the acid comes in. Oxygen grabs the hydrogen, kicks off the acid. The oxygen has a positive charge. From this place, the ROH comes in, the carbon chain. It attacks the carbon where the double bond is at, and gives the electrons to the oxygen. From here, break it in half like this. We have OH, the alcohol on the left, and we have the carbon chain with the alcohol on the right with the positive charge. In this case, we have the acid comes back, grabs the hydrogen, and gives electrons off to the oxygen. In this case, now we make the hemiketal. The hemiketal. I know I wrote hemiacetal, but ignore that. It should be hemiketal. hemiketal for ketone. Now in this case, the HA comes again, grabs the hydrogen, kicks off the acid. Now in this case, the OR stays there. We have this water forms, positive charge. Now that oxygen forms a double bond and kicks off the water. So we lost water during this reaction. We have this structure right here where we started with this positive charge. Okay, we know that we lost water in this case. Now we have the carbon chain to come back. The alcohol, the carbon chain, kicks it off like this. And we would have a product that would look like this. Lone pairs. R, and then a hydrogen connected with it. From here, the acid will come back, grab the hydrogen, and give electrons to oxygen. We have a final formation of this. A ketal is formed. We have a ketal form in this case. So this was like about a 7-step mechanism, and so that's it. Let's do another example here. We said that this is a reversible reaction, so let's start backwards. But this time we have an aldehyde, right? We have that H, right? The H, we have a acetal, but it's the same thing as a ketal, right? Aldehyde and ketone has the same mechanism, so it doesn't matter. So if we do this backwards, we would get a product that would look like this, right? We should get that if we do the mechanism correctly, right? We form an aldehyde. So we start off with the acid coming in. It grabs the hydrogen, kicks off the A. Now we have this forming with a positive charge on the right. From here, it forms a double bond and kicks off the methanol. We have a double bond here with a positive charge. From this case, water comes in. Okay, water comes in and attacks the carbon, kicks off the electrons to oxygen to make it neutral, stable. We have this structure. We have water here. And we have the OCH3. Now we have positive charge there. So the acid comes here, grabs the hydrogen, kicks it off the electrons to oxygen. In this case, we would form the OH and the OCH3. In this case, we see this is a hemi-acetal, right? Don't forget the hydrogens. Okay, the hydrogen. This is a hemi-acetal. We begin with a acetal, right? Because we're going backwards. And now we're with a hemi-acetal, so we're halfway there. We want to get to an aldehyde. From here, the HA comes again, grabs the hydrogen, kicks off the A. We have a formation that would look like this. OH, the alcohol on the right. And then we would have this as a positive charge, oxygen. From here, that forms a double bond and kicks off the methanol. We have a double bond OH. From here, our final step is that the acid comes back, grabs the hydrogen and kicks off electrons to oxygen to give our final product of this. And so what we had made in this mechanism is what we said we were going to make. And this is an aldehyde. Don't forget the hydrogens. So this was a 7-step mechanism again. So if you're going forward, it should be the same amount of steps that you're going backwards.